In this tutorial, we'll see how to project shadows onto shots interactively, and how to change the position of the layer or the light source that generates this virtual shadow so that it is projected automatically onto the floor and walls. We need a layer with mask and a background with two walls and a floor at right angles. We will add a Comp 3D effect to the layer to be composed, and to this effect we will add a feedback effect to obtain an updated copy of the layer in its new position. Another feedback effect without input will be positioned underneath the background layer. The Show Alpha effect allows us to see the repositioned mask of the layer, which will be assigned as the external mask of the background via the external key effect. An RGB correct effect is added to the background flow, and finally, with a Comp 3D effect, the figure with the background is composed. The Comp 3D effect used to compose must be pre-multiplied in layer 1, and the Comp 3D effect used to reposition the layer must have the attribute background set as no, in order to affect the position of the layer that will project the shadow. We use the effect RGB correct to reduce the brightness of the background, restricting its effect to within its mask. The mask of the shadow and the layer are in the same position. To see the shadow, we offset it with a third Comp 3D effect, but this shadow isn't projected onto the walls or floor yet. We can, however, edit the way the shadow finally looks by adjusting the values of gamma and the restrictions to brightness levels of the background which the shadow will darken. We now come to the most important part of this tutorial, the distortion map, which we will create by adding together 3 grade effects and 1 Comp 3D. To be able to see the map easily, we add a non-linear mix effect, which allows us to mix the background image with the distortion map. In the Comp 3D effect, we set the background as no, and adjust the camera in order to match the front wall with the rectangle defined by the layer. We add 2 layers to the effect in order to control the position of each grade effect individually. We set the pivot of layer 2 in its right border in order to rotate the layer 90 degrees around its vertical axis to create the side wall. We set the pivot of layer 3 in its lower border and rotate it 90 degrees around its horizontal axis to create the plane of the floor. We scale the layer of the floor so that it is at the same depth as the layer that creates the side wall. Having rotated the layers that create the side wall and floor, they are differently affected by the default light than the front wall. We should avoid this by setting the ambient light at its maximum value. We adjust the junction of the planes by carefully closing them together. The grade effects have 4 corners. We darken the corners that are closest to the 3D camera. We have created a distortion map which simulates the depth of the background on a gradient from black to white. Closer to the camera it is darker, further away it is lighter. We now position this map underneath the mask of the background. Within the legacy effects, we can find the effect Distort. This effect works with 2 inputs. The first will be the shadow, the second the distortion map created. Selecting the effect Distorts parameters folder, we can interactively position the virtual light source that will create the shadow. We'll see that the pivot point of the projection does not correspond to the base of the layer. This is because we have not defined the 0 value correctly. The waveform monitor can help us with this. By right-clicking while holding Control, we can take a sample of the value of the pixel that corresponds to the base of the layer. We can now view the distortion map. The waveform indicates the depth at which the layer is positioned, in this case approximately 30%. We set the zero value of the distort effect at this value. Now when moving the offset parameter of the effect, the shadow will have the correct pivot value. If we reposition the layer in its vertical axis, we must reset the value of the zero parameter. We can check the value of the pixel where the layer makes contact with the floor, viewing the brightness value in the distortion map. It now appears as 12%. Some extreme values can cause the shadow to be lost, so they must be avoided. There may also be some curvature in the direction of the shadow. This is because of the way the range of the distortion map is interpreted. We can resolve this problem by correcting the range of the grade effects with RGB correct. Now the shadows are straight, but the zero value has been lost. In the distortion map, the grey values have been modified to improve the distortion. The value of the layer contact pixel is no longer 12%. It is now close to 25%. We update the zero value of the distort effect, which allows a final interactive adjustment from its parameters. The shadow is now projected without curves. If we reposition the layer only in the horizontal axis, we do not need to adjust the zero parameter. But when we reposition it vertically, we must recheck the pixel at the point of contact with the floor in the distortion map and reset this value as a new zero.